What's up, guys? We're back in the lab today with a water bottle, a blowtorch, a box of matches, and an oversized martini glass because Darshan Mathukia wants to know what would happen if we tried freezing gasoline, then lighting it on fire. Freezing gasoline and liquid nitrogen is one of my highest requested videos right now, and this comment got over 418 likes in 1 hour. That's why we're doing it today. Will frozen gasoline burn? That's the question we're here to answer today. I want to tell you about my water bottle. Yes, this actually is my water bottle, but just a few minutes ago I ran down to the gas station and filled it up with 91 octane premium gasoline. The octane rating refers to how much pressure the gasoline can take before igniting, and I got the highest stuff we could get. Now we know that gasoline in its normal state is a liquid and it's highly combustible. It's extremely flammable and it's what we use to run our vehicles. If we pour a bit of it onto my brick here and light it off, you can see it goes up in flames. The question though becomes, what will happen to frozen gasoline? Gasoline has a freezing point anywhere between -40 to -50 Fahrenheit and Celsius, so we could probably use liquid propane, liquid butane, or anything else like that to freeze it. But for quickness and convenience in this project, I'm going back to my old friend liquid nitrogen. So first things first, we need to transfer our liquid nitrogen into our giant martini glass, and hopefully it doesn't break as we do. All right, that's enough to make me feel uncomfortable. Here comes the boil. This is my favorite part. Whoa! Uh-oh. If that glass lets go, it's gonna spill all over the workbench. It's cracked like crazy on the bottom, and it's working its way up like spider webs. Oh no! Oh, it's all spilling down the side here. Look at this, look at this. We've got a leak. That's not good. Our martini glass has turned into a spider web of cracks. That didn't really take very long, and honestly, I wasn't expecting anything different, but that is $13 down the drain. Okay, I am gonna see if I can salvage any of this nitrogen here. So, liquid nitrogen in a martini glass? Not so much. All right, attempt number 2, ceramic bowl. Look at the way it boils up around the edges. It's jumping to get out of the bowl. All right, guys, it looks like our liquid nitrogen has sufficiently cooled. What's really interesting, it takes so much nitrogen to cool the dish down, we lose more than half of the bowl just in the cooling process alone. Now, you know that nitrogen itself is not flammable. We can demonstrate that by dipping a match into it here. And you can see the match goes out as soon as it hits that top layer of nitrogen. The time has come to add our gasoline, and what I'm thinking is we'll just pour a few drops in there and see what happens. Here we go. Oh, wow. Interesting. Look how dense that vapor is. It turned white and came out like a mushroom cloud. And if I push that away, you can actually see the gasoline is floating on top of the nitrogen right there. That's interesting. And it's still liquid. It hasn't frozen yet. It's almost like it's got a protective coating around it. But there, it's starting to get hard now. Perfect. We've got a very small sample size here I'm pretty comfortable with. So let's go ahead and pull that out and light it off. There we go. There we go, my friends. That is frozen gasoline. I'm actually gonna pour a little bit more in there. That is so cool. I've never seen this before. I wasn't expecting such a rich white fog. Ooh, look at that. It's like a gasoline slushy. Well, it's actually like solidified into a bunch of globs of gasoline. The thing that's really interesting to me about this is how white the gasoline is. I thought it would have more of a yellowish tinge to it, but that's pretty clear, pretty white. Very impressive. What happens if I pull one of these pieces out? The gasoline melts extremely quickly, so I'm dipping my tongs in here to cool them down, and that'll give us a little bit more time to work with this stuff. We'll hold them in the tongs, light the edge, and see what happens. Here we go. Frozen gasoline versus fire in 3, 2, 1. Whoa! Interesting. So I don't know if you noticed that, but the second the two made contact, it spittled and almost exploded. I saw kind of like, it almost looked like white flames. It happened very fast. But it definitely lit off, and as the flames grew, it melted all the gasoline and just burned like normal. That was interesting. Let's do some more. 3, 2, 1. Amazing! So will frozen gasoline burn? Apparently it does, and it takes off with a very, very vigorous ignition. So for this next experiment, I'm thinking let's just scoop up a bunch of chunks on a frozen spoon like this and touch a match to the top and see what they do when they're all congregated together. Gasoline soup. Cool, here we go. Holy heck, that was vigorous. Oh, my workbench is on fire. And here's the best part, a little nitrogen vapor waterfall. Battle of the elements. Hot versus cold. Hot is winning. Let's try at the base here. Our nitrogen fire extinguisher. It's pretty cool. So, did you see how vigorous that reaction was? Like the second I put the flame into the spoon, it would just pop, crackle, and it just went crazy. Almost explosive, which is very interesting. So I think at this point, it's pretty much confirmed. Frozen gasoline does burn, even at the temperatures of liquid nitrogen. And what's really interesting is how much energy it still has at those cryogenic temperatures. Let's do it again. It spits. And then the rest turns to gel. Gelled gasoline. Quick, use the nitrogen fire extinguisher. Oh, look at that. We got a river of nitrogen flowing through the center of a valley of fire. I'm just playing with it a little. I could put it out if I wanted to. Whoa! That's cool. The way they dance around. That's neat. So for this last experiment, I'm going to try pouring a whole bunch of gasoline in at once to see if we can freeze one big giant solid chunk. That's quite a bit. You can see little bubbles and spats of gasoline freezing. It almost freezes like ice. I mean, that looks really cool. You know, one thing I'm thinking, what would happen if you took a match and threw it in to the gasoline and nitrogen combined? Would it even light off, or would the nitrogen vapors suppress the ignition? If it does go off, it's going to be a pretty dramatic display. I don't know what's going to happen. My guess is the flame will go out, but if it doesn't, this is going to be spectacular. Here we go. Ah! Nitrogen barrier. Let's see that again. I'm a little more confident this time. Here comes the flame. Can't even get to the gasoline. Here, let's do this. Let's light a little bit of gasoline up here and then put it down into the mix. And it goes out. Whew. That's pretty cool. All right, guys, for one grand finale, we're gonna light a match and throw it into this container with gasoline and nitrogen combined. There's a lot of gasoline in there, and the pillars are just high enough, I think we can actually get them to ignite. Here we go. Whoa! Whoa! Yikes! Woo! Craziness! Oh, that's hot. Well, I do have a fire extinguisher. I don't really want to use it though. I don't want to use my fire extinguisher. I'm just gonna put this out manually. Stop, drop, and roll, right? We gotta smother that fire. I need a wet rag. Oh wait, never mind. I'm doing okay. Did it! Holy. Oh my goodness. That's incredible. All right, sweet. Lesson learned. Well, it's actually really impressive how well my workbench held up to all that. I'm super impressed. You might think that was stupid, but I was actually expecting that to happen. So let's talk about what just happened here today. We started out with the purpose of trying to see whether or not frozen gasoline would ignite. And not only did we find that it does ignite, but it actually bursts into a very energetic flame. Next, we tried freezing a spoon and scooping up multiple chunks of gasoline and placing a match down in the middle, where we found that it burst into flames, spattered around all over the place, eventually liquefying the gasoline and returning to burn like normal. We found that if you take a lit match and place it into a container of liquid nitrogen, it will go out every single time. But we also found out that if you have enough frozen gasoline in the container, it can take off with such a vigorous reaction that it can bypass that nitrogen layer, suck in all the air that it wants, and cause a massive explosion, which almost resulted in an insurance claim. So in conclusion, I think we can confirm that frozen gasoline will burn. Not only that, but it burns in a way that completely blew my expectations. And of course, a big thanks to Darshan Mathukia and everyone else who's been requesting this experiment. Check your YouTube inbox, Darshan. I'm sending you $25. That's it, guys. Thanks for joining me for this experiment, and I'll be looking for you in the next video. Talk to you then. Well, that escalated quickly, didn't it? Hey guys, thanks for watching, and remember, I'm giving away prizes now on every new video. All you have to do to qualify is subscribe to my channel, ring the bell, and select to be notified when my next videos get released. The secret link to my giveaways will be pinned in the comments for the first 12 hours. If you like what I'm doing, show your support right now by giving this video a big thumbs up and share with a friend. I love you back, and I'll see you next time.